Morning everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I'm going to explain about channel coding theorem. Channel coding theorem, it is nothing but what is the need of this is the presence of noise in the channel generally causes discrepancies between the output and the input data sequences of a digital communication system. For example, in wireless communication channel, the error probability may be n power minus 1. That is, we'll call it as a 9 by 10 which will be received correctly. But in many applications, this level of reliability is unacceptable. So a probability of error equal to 10 power minus 6 or even lower is often a necessary requirement. In order to achieve that requirement, we have to use the channel coding. The goal is to increase the resistance of a digital communication system with the channel noise. The noise present in the channel creates unwanted errors between the input and the output sequences of a digital communication system. The error probability should be very low, nearly less than or equal to 10 power minus 6 for a reliable communication. The channel coding in a communication system introduces redundancy with a control so as to improve the reliability of a system. The source coding reduces redundancy to improve the efficiency of the system. Here the channel coding consists of two parts of an action. One is a mapping, another one is a inverse mapping. Mapping here the incoming data sequence into the channel input sequence. Inverse mapping is nothing but the channel output sequence into an output data sequence. The final target is that the overall effect of the channel noise should be minimized. The mapping is done by the transmitter with the help of an encoder, whereas the mapping here, in the inverse mapping, the mapping is done by the decoder in the receiver. This is nothing but the channel coding process. Here the channel coding consists of mapping the incoming data sequence into a channel input sequence using the encoder and the transmitter and the decoder. Whereas at the reverse, the inverse mapping, here the output sequence into an output data sequence is being mapped in such a way that the overall effect of the channel noise on the system is minimized. Here first we'll be giving the source to the discrete memoryless source where it is being given to the channel encoder where the source is being given to the encoder in order to encode the particular data. Then it is being finally given to the discrete memoryless channel. Here for the complete channel, here the encoding is being done and it is being given to the channel decoder where decoding process takes place over there and finally it is being given to the destination. So let us consider the discrete memoryless source channel as a del and entropy as a h of del, where it is indicated by the C, the data sent which will be equal to h of del by Ts. So it means the transmission is good and can be reproduced with the probability of the error. In this, C by Dc is the critical rate of the channel capacity. Then the system is said to be signaling at a critical rate. Conversely, this H of del by Ts is greater than C by Dc, then the transmission is possible. Here, the maximum rate of the transmission is equal to the critical rate of the channel capacity for reliable error-free messages which can take place over a discrete memoryless channel. This particular critical rate of the channel capacity will be calling it as a channel coding theorem. So the process of this involves it introduces redundancy in the channel encoder so as to reconstruct the original sequence as accurately as possible. Then code rate. Code rate is nothing but the ratio of message bits in a block to the transmitted bits by the encoder. Then code efficiency will be called it as a code rate. So which is equal to number of message bits in a block by number of bits in a code word. Code rate R which is equal to K by 1 which is always less than 1. So channel coding is efficient when the code rate is high, which can be defined as the average information rate of the source which will be equal to h of s by ts bits per second. So, in channel capacity theorem, it is important to note main 3 points. It does not show us how to construct a good code. It doesn't have a precise result for the probability of a simple error after decoding the channel output. Then the power and the bandwidth constraints also hidden here. Assessment, define channel coding theorem. Then what is mean by mapping and inverse mapping. Then define code rate. Thank you.